Alright, so perfect. It drove fantastic. No limp home mode. Let's go back to transmission, see if anything was stored. All this crap. Let's see, clear codes, yes. Okay. No codes present in the transmission control module. Let's take it for another spin. Alright, so powers and grounds at the PCM TCM unit. Transmission control module here. Very fine print says 3.7 liter only, so that's not us. We just have a PCM with 4 plugs, the classic, you know, later Jeep style or Chrysler style. So we're interested in powers and grounds to this PCM. All right, so let's go to diagram, do a little wiggle check. Right now the truck is running and looks happy. It hasn't sent any codes in the last test drive. So what can we do? Pop under the hood. Here's our guy. I mean, this thing is burning hot in the engine compartment. I can't keep my hand on there. So if something's cooked in there, I wouldn't be too surprised. We can just let it heat soak. See if our codes come back. Because they definitely did before. See if it's a common failure in Commanders to have a busted ECM TCM unit. But while it's idling here, I'm going to look up a wiring diagram. So in cases like this, research is absolutely key. I'm not so much worried about a network problem anymore. We're worried about this TCM code, the power up code, the 882 and the 884. So 882 TCM power input low. First we have a diagram, 10 amp fuse or 20 amp fuse, relay transmission control in PDC, which is controlled by the PCM, and then it feeds all the solenoids in the transmission, and also 2 sense wires at the PCM. I don't know why they have 2, actually 3. 1, 2, 3. So let's read. The DTC set when less than 3 volts are present at the transmission control relay output circuits at the PCM when the PCM is energizing the relay. So it could be as simple as a bad relay. Here we go. Possible causes. Relay output circuit open, short to ground open, relay ground circuit open. So basically, if this relay is commanded on, and either there's a problem here in the relay or in the power feed, then we'll get this 883. Theory of operation. The relays used to supply power to the solenoids and pressure switches in the transmission, and the relay output is fed back to the TCM through pins 16, 17, and 36. The circuit does not supply power to the TCM, it's only a sense circuit. Why do they need 3 wires? I don't know. When the relay is off, no power is supplied to the solenoids and pressure switches. Transmission is in limp-in or default mode. And inadequate transmission control relay output voltages can also set these DTCs. Does not indicate internal transmission or solenoid problem. Alright, and the 884 is power up at speed. This is what happened to us on the test drive. again, the same exact circuit here. This is the relay output, and then it goes to the solenoids. When monitored, PCM initially powers up due to integration of PCM, TCM. They have separate power and ground circuits. This DTC will say if the PCM powers up and senses the vehicle is in a valid forward gear with no Prindle DTCs and output above 800 RPM. And basically, this code identifies the power to the transmission control system was restored when the gear selector was in drive position. The vehicle is moving at speeds above 32 miles per hour, or 20 miles per hour. So the power was restored to the TCM. So we're dealing with either a bad relay or a problem with this connector or something. So basically the next check is, forget the CAN circuits, let's move our scope to this power transmission control relay, the relay control wire, and the sense circuit. So it's all in C4, yellow and brown, yellow and orange, easy to back probe, and we'll see what happens when you turn the key. This thing should power up, and we should get power at the sense circuits. Hopefully we can recreate this problem again. Alrighty, in the fuse box, our transmission control EATX relay is right here, so we know that. We'll leave it alone for now. And our wires, so two wires we're interested in is the control wire for that relay and the sense wire for when the relay's powered up. Yellow and brown, and one of the yellow and oranges, there's three of them. I just back probed one, or poked a hole, if you will. This is connector C4 going to our ECM, PCM, TCM thing. So we got one wire, two wires. Let's plug it in. And see if we have any issues with either the control or the load. Hopefully we'll see something. Is that plugged in? Should click, I think. There we go, clicked in. Let's fire up the scope again. Alrighty, here we go. Control wire is at 0 volts. Sense wire is also at 0 volts. So put the key on. Boom, instant. What was that? I guess not too worried about it. Fire it up. It's powered up. Now we just have to recreate the problem, which might be not easy. Let's take it for a spin. Well, now that we know what tests to do, I can't get the damn thing to act up. Annoying. So keys on, the relay is powered up. Control wire is, let's see, should that be high? Let me double check something. Yes, looking at the diagram, the control is actually a pull-up design and the relay is grounded at G100. So all we can do now is look at the scope. The relay is powered up. The sense wire is steady at 12. Just do wiggle checks. Tap on the relay, wiggle stuff, wiggle the harness. There's a bad ground somewhere. I don't see any signs of even remotely, changing those signals. Not that I haven't seen bad relays before. If it's stuck off and the computer commands it on and says, hey, we got no power, what we can do is, for example, AC clutch, not as important, so we can swap these two relays around and see if the problem disappears. So if I take this relay out, check what happens to the signals. You see the output went away. Alright, so let's swap it with, it's high, really high, with the AC clutch relay. So now it's at 0 and 0. Interesting. Let's see what happened on the scanner. Okay, key off, key on. Everything's good. Yep, we're back up to 12 volts. What we can do is bring our laptop where we can see it and just play with the key on off and see if the relay is working as it should. Looking at the two traces. So keys off, keys on, off, on. The relay's working just fine. So at this point, we'll double check for codes, but I'll say take it, drive it. If this problem ever happens again, it's not the relay. If his like AC stops working, then we'll know it was the relay. You know. So let's just back out of here. Any code stored? Closed loop fueling not achieved. Bank 1 upstream. Okay. It sets different codes every time. I just don't get this thing. Codes only. TCM power input low pending. That's what when we pulled the relay. Let's clear those out. So at least we recreated the fault by pulling the relay. That kind of makes me feel good. That otherwise, you know, wiggle check didn't show anything. It could be just the relay that when it's cold it wouldn't switch, or the contacts in there are pitted or something. And when it's warmed up, it's doing a lot better. So continue, no more codes. Back to the engine. It's going to give me that fueling code. Multiple cylinder misfire, of course. And take a quick look at the O2 sensors again. Let's see, 1, 1. Even have goals. Oh, so you can see 0 to 1. Okay. 0 to 1. 0 to 1. 0 to 1 and 0 to 1. And also let's look at our short term and long term. One, 1 and 2, 1. So they're both working. So maybe if it has a, sounds like it has an exhaust leak, you know, at the exhaust manifold, that sensor is stuck lean because of that exhaust leak. And then it closes up once the engine warms up, then, you know, we could definitely explain that problem too. Anyways, I guess the catalytic converter isn't doing too much. Pink 1, sensor 2. So replacing an oxygen sensor wouldn't do much there, would it? There we go. Hey, now the fuel trims look freaking fantastic. Well, I think that's about it. If the relay acts up again, I'll turn the camera back on, but right now we suspect the transmission control relay for the limp home mode. Otherwise, it can be. That was kind of a little rabbit hole because the guy said, hey, it runs bad and it says U code, so we started chasing U codes. Not the right approach here. The scope is key, and that's it. Thanks a lot for watching. See you guys next time. Bye-bye. Bonus footage. I got the thing to act up. I went to read the codes the last time, and it was in 3. The transmission was in 3. Alright, so we're back in the 2 channels. Our relay's off. 0 volts and 0 volts. What happens when we turn the key off and back on? Ah, bingo. Did you see what happened there? I turned the key to on and the relay switched off. The PCM actually switched it off. Not a wiring problem, not a relay problem. Why did the PCM switch that off? That is my question. It's a control side issue. So if you go back to the diagram, what's happening here is, sorry for the sideways look, we're losing power from the PCM to the relay. So the relay shuts off and obviously you get no power back at the sense circuit. The ground is fine, the feed is fine. Why is the PCM shutting off the transmission control relay? Well, save this capture and then poke around a little more. By the way, one variable here, keys off, key on, it switches it off instantly. Key off, key on. Doesn't like something. What doesn't it like? Keep in mind the blue trace is the control. Consistent. So is it the driver inside the PCM? Do we have a data PID on our computer saying command relay on? Let's look. Another experiment. I let the engine run for, I don't know, like 15 seconds, and now that relay is on consistently. I mean, the control's there. I'm going to let it sit again, see if we can recreate the problem. The camera's battery's dying, but here's a test. Data PID. I took out the transmission control relay. You can see the switched battery voltage is now 0 volts. What does the control side do when it doesn't sense an output of the relay? So keys on, it tries to turn on the relay, and boom. So for about 5 seconds it tried, and then it shut itself off. However, when the fault was happening, it was turning on, the sense was definitely there, and it was shutting right back off for no apparent reason. That's what really blows my mind. Why would it shut off on its own? Now, bonus footage, of course. We want to condemn this TCM or PCM 100%. Right now, we see that we're losing the control for no apparent reason. There's no logical reason. This should be shutting it off in half a second. So I called Keith. I'm like, Keith, code 0882, does that mean a bad TCM? So he looked at some wiring diagrams together, looked at the code setting criteria, and he came to the same conclusion, that there's no reason for the TCM to shut off that driver within half a second. Basically, the driver can't stay on for whatever reason. It needs a box. If we can't reproduce it, can we load that driver a little bit more than a relay, to see how much it can output? It's a, you know, pull-up design. So the test is out here. We have a 1 amp test light that I hooked right into the back of the control wire for that relay. I also have an amp clamp on that same control wire. So this is a 1 amp test light, half an amp per filament, low side, or the tail light filament, not the brake. Lower amperage. So what happens when we turn the key on? Let's see. Key on. Boom. In half a second, that's the exact same pattern that we saw when it was acting up. Now, let's disconnect the test light, repeat the same experiment. Okay, test light is disconnected, scope is rolling, key on. It keeps the relay on, as it should, so it's working fine now. And the current draw, I have an amp clamp on there, 6 millivolts, and 1 volt is 10 amps. So 100 millivolts would be 1 amp. 10 millivolts would be 1/10 of an amp, so this is less than 1/10 of an amp, about 60 milliamps. That's normal relay. Shuts off, turns on. Right now, it's fine. Let's turn the test light on again, or plug it in, and the results I'll show you are inconsistent. Alright, here we go. Test light's reconnected. When I turn the key on, let's see what happens. Look at that. Oh, it failed. Right away. So now, with no test light connected, it's failing. Same exact pattern. We're not loading that circuit anymore, but it's still failing. Unbelievable. I wanted to show you a cool capture with the test light connected, and it can actually light the test light. The voltage here drops to 8 volts, and then it's like, I can't light it anymore, and boom, shuts the relay off, and you're done. So it's a TCM problem. Now it's, you know, that, oh, here we go. It's staying on, right? Pretty cool. Let's shut it off. Connect our test light. Having way too much fun with this thing. So connect this to ground. Now watch that bulb and watch what happens on the scope. This is too cool. So key on, and there you go, lights up. Look at what happened. Oh, it turned off. It's inconsistent. And now it's back to its failure mode. Here we go. Nope. Just kept it on for a little bit. Now it's back to that. So it's, you can see that something's happening with that driver. It's either heating up and you can't stay on. So when this thing gets really hot under the hood, that driver might get really hot and this problem will happen. That's it. Needs a box. Hope you enjoyed that bonus footage. I thought it was pretty cool. Hey, more bonus footage. Lights staying on dim. It's at 8 volts. Look what's going to happen to this driver. Oh, man. And boom. The relay shuts off. The driver's like completely... Now it shut off on its own there. But look what's going on here. Something different happens every time. It's oscillating. Isn't that crazy? that's enough to keep the relay on. Right there, it shuts off for a couple milliseconds and the relay starts to turn off. Then it turns back on. Finally, it's just not enough to keep the relay alive. It turns off. I mean, that's just cool stuff. Hi everyone, I hope you enjoyed the Jeep Commander case study so far. I thought I would do a quick follow-up to answer any leftover questions and give you an update what is going on with the vehicle. So first, to 100% finish up this diagnosis, my camera battery ran out at the very end. I got excited when I saw that driver in the TCM start dropping out and the relay wouldn't switch on. So yeah, that's the problem. What's the last thing we have to check on, to make this relay power up? We're losing this power to the relay, and then the relay doesn't switch on and it doesn't provide power to the TCM. It's kind of goofy design. It's like the TCM switches on in the relay to power itself up. Yeah. So we're losing this control. What are the variables here? Obviously we could have a bad driver in the TCM, or powers and grounds. You can see when you turn the key on, it tried, and sometimes it would just go boom, half a second, drop off. Sometimes it would kind of hang out and then drop off. It was like an instant shut off. When we loaded it up, it was acting funny. So I suspect bad driver, but we still have to check powers and grounds at the TCM, and that's the last thing that I couldn't show. Power distribution diagram, or ground distribution. This TCM connector C4, we have 3 wires, pins 12, 13, and 14. They're blacks. All I did was put a test light on there from power. Boom, it lit up nice and bright. And that makes sense. In this case, obviously check your grounds, but if G101, if that was bad, green and crusty, let's see what else is on G101. Everything. Oxygen sensors, the EGR, the power, integrated power module, front control module. They're all tied to G101. Oxygen sensors. The rest of the vehicle still work. We're just concerned about that one circuit. So, this stud being green and crusty, that's not the case. And where this thing is located, it's actually, I found it was up on the firewall, nice dry spot. No green crusties up here. That's G101, right by that power distribution module. So yeah, bad TCM, 100%. What's going on with the vehicle currently? Now we got a guest in the background. What are you doing over there?
Looking for duct tape until you
duct tape? That's not going to fix your horse?
It went against the Gorilla Glue over good old duct tape.
Oh, you got to patch them up, huh?
Yeah, I'll try to remember to bring this back, otherwise I'll get the wrath.
Oh, no, it's okay. I got plenty of rolls of duct tape lying around. My wife, she's fixing horses, I'm fixing cars. So, what's going on with the Jeep? I keep calling the shop owner. I wanted to get a confirmed fix before posting this video, but the customer doesn't have any money. They don't want a new computer. They're just still driving in limp home mode. So, unfortunately, that's how it goes when you do the mobile diagnostics for another shop. You don't have a direct line to the customer. You can't talk to them and, give them any estimates. You just do the diag and leave. So the conclusion, I also want to find out what's going on with this thing, but unfortunately we may never see the Jeep again. It might go to the scrapyard, and I have no idea. So that's the wrap up. Thanks a lot for watching. Leave your comments and questions below, and happy 4th of July. See you next time. Bye-bye.